Concept D is now going to focus on changes of matter. You might want to go back and glance at Concept A where we talked about properties of matter, because this is just going to extend your knowledge a little bit more. So by the end of this video and the lesson in class, you should be able to distinguish between chemical and physical changes. You should also be able to explain how the masses of reactants and products relate to each other in various chemical and physical changes. Alright, so let's first look at changes. Well, physical changes, the appearance changes, but not the actual chemical composition of the material that you're looking at. So when ice melts into liquid water, in both samples we have H2O present. So while the appearance of the water changed, the chemical composition stayed the same. No new substance forms, the same particles are just simply rearranged differently. So in a solid, the particles are in nice, neat, organized rows, and then as it melts, they become more disorganized, moving slightly apart from each other, but also basically in a more irregular state. So examples of physical changes, this could be changes in state, like I just talked about, which can go through boiling, freezing, melting. Changes of appearance, so if something dissolves, that's considered a physical change. Changing of shape, if I either hammer a piece of metal flat or I take a piece of metal and draw it into a wire. And then also change of size, whether I cut or rip something into pieces or if I grind something into tiny particles. All of these cause a change in how the material appears, but no change in the chemical composition. Now, chemical changes involve changes that happen at that particle level, where the composition of the material is entirely different after the change. So we have something new that's been formed. So a new substance is formed. This really can only be reversed by another chemical change, if possible. So this new substance, I start with water, and then through a decomposition process, I have oxygen and hydrogen formed. So I have new substances that were, yes, bonded together in the water, but here they are rearranged. New bonds have been broken, new bonds have been formed. So here is that example. We can take water and decompose it into hydrogen and oxygen gases, but I can also take that hydrogen and oxygen gases using energy and form water once again. So I can reverse it in that case. Some examples: burning, corrosion, rusting, combusting, decomposing, tarnishing. These are all keywords that indicate a chemical change. Now, changes in energy relate to this. Both chemical and physical changes involve changes in energy. Either releasing or absorbing energy. If a change does release energy, is considered exothermic. We see energy is placed on the right-hand side as a product because it's being given off. So it was within our reactants, and then once they formed a more stable compound, they then release a huge amount of energy. Now, we also can absorb energy through various processes. This is a little bit less common than exothermic, but in this case we can see that during this phase change from a solid to a liquid, it has to gain energy, so endothermic is on the left hand side of the arrow. Alright, we also want to look today at conservation of mass, that during these chemical and physical changes that we just discussed, mass is always conserved. So matter cannot be created or destroyed by any of these changes. They can only be converted from one form to another. So if I have 35 grams of liquid water that's evaporated in an enclosed container, how many grams of water vapor will there be when this process is completed? There has to still remain 35 grams of water vapor. So if I started with 35 grams of liquid water, through the evaporation process, I would still have 35 grams now of water vapor. Here I have that magnesium metals reacted with oxygen to form magnesium oxide. How will the mass of the magnesium oxide compare to the masses of magnesium and oxygen that formed it? Well, here we have the process, and we know that if mass is conserved, the mass of magnesium oxygen must be equal to the mass of the magnesium oxide. So the sum of the masses has to be equal to the product. Here we have actual amounts, so if 40 grams of substance A are reacted with 20 grams of substance B to form substance C, what will the mass of substance C be? So if we set up a little reaction here, A plus B is going to produce C, and I know I have 40 grams of A and 20 grams of B. Through the conservation of mass, I know that C must be equal to 60 grams. Alright, so here, pause the video and do some of the practice questions that are in the dotted box in your note packet. So which process results in a chemical change? So again, we're looking for which of these is going to cause the composition, the chemistry or chemicals to change and how they're rearranged. So look for those keywords which would indicate D, burning, and magnesium ribbon. So burning being the keyword for a chemical change. The other three are all making an appearance change, but not changing the chemical composition. Here, based on the law of conservation of mass, predict the minimum amount of magnesium that will react with all 16 grams of oxygen to produce 40.3 grams of magnesium oxide. So setting this up, magnesium being our missing variable, plus oxygen giving and producing magnesium oxide, X or magnesium must be equal to 24.3 grams. Alright, so that is it. We've talked about now changes of matter and also gone into a little bit with the conservation of mass. So come ready tomorrow with your notes.